In this demo we shall see how we can use the join entity that we've just created to change the way that we've mapped the relationship between item and orders from an approach using skip navigations into an indirect relationship. Before we start on the demo, let's just take a quick look at what we'll be doing to our entities in order to map the many-to-many relationship indirectly, using the simplified implementations of the item entity that we see here to showcase what we'll be doing in the demo. The reason why the implementation that we had before is called a direct relationship is that it deals directly with the two entities involved, just like we see here where our item class contains a collection of orders, and as we know from the code, the reverse is also true. In order to change this into an indirect mapping, all we need to do is change the orders collection so that it contains the item order join entity instead of the order entity. Since we now map the relationship using the item order as an intermediary, we call this an indirect many-to-many mapping. But of course we can't just change the content of this collection without it having consequences elsewhere in the code. So after having made this change, we will also have to change all the places in the code that uses the skip navigations on our order and item entities. This of course also means that this is a more invasive change than when we just used the item order entity to add payload data to our skip navigations. But it comes with the advantage that accessing the data on the join entity becomes much easier, as we shall soon see. And of course we'll also need to make similar changes to the order entity. We're now back inside Visual Studio and are looking at the item entity. As we can see, the orders collection has been replaced with a collection of item orders, and the collection has been renamed to item orders. And if we take a look at the order entity, we can see that the same changes has been made here. In order to make this work, we'll also need to set up a few things in the database context. So let's take a look at that. Here we see the code that has been created to implement the indirect many-to-many relationship between items and orders. The first part of this was of course to start using the item order entity for the collections in the item and order entities. But to make sure that AF_Core sets up the relation correctly, we need the code that we see here. The setup that we did in the previous demo, where we used the item order entity for the skip navigation, has been commented out. So AF_Core will instead use the configuration that we see here. This configuration looks quite similar to what we did when we set up the skip navigation on the order entity, but this time we are configuring directly on the item order entity. The first thing that we do is to set up the one-to-many relationship between the item order and the item entity using the items ID foreign key on the item order entity. And then we set up the one-to-many relationship between the item order and the order entity using the orders ID foreign key on the item order entity. Next we set up the primary key for the item order entity, once again specifying that it's a combination of the items and orders IDs. And then we define the default value for the order date, just like we did before. In essence, what we've been doing so far is to make sure that making the switch to mapping the many-to-many relationship indirectly in our entities will not lead to any changes in the database. What we're trying to do is purely a matter of modeling the relationship differently in our C# code, and it is not born of any intentions to modify the underlying model in the database. So to make sure that we don't change anything in the database, we need to do one last thing which might not be so obvious. When we were using skip navigations, both without payload and when we introduced the payload by using the item order entity, we benefited from the fact that AF_Core automatically set up the item order join table for us. In doing so, it employed some different naming conventions than it would have done if we had used the item order entity as join entity from the start. And one example of this is that it did not pluralize the name of the item order table. So if we take no further action and create a migration based on these changes, it will, as we can see here, contain changes that we are not interested in making on the database. As we can see here, it is dropping keys from the item order table. But the real culprit is here, where it renames the table from item order to item orders. This we want to prevent. So if we head back to the database context, we can see that there is a call to the toTable method on the entity, where we explicitly tell AF_Core that we want the table to be called item order. With that line in place, creating a new migration will simply result in an empty migration file. The last thing that has been added to the database context is this database set, which we can use to fetch items from the items order table directly. This is not strictly necessary, but there may be cases where it's desired, so this is just to show you that it is done in the same way as for any other entity. We'll also shortly see that we can fetch these items just like we normally would. So if we head over to the program class in our console application, we can start trying to fetch data from our entities using our new indirect mapping. Now that we've created our new indirect mapping to the many-to-many relationship, let's take a look at how we can interact with it. Much of what we see here repeats what we just did when we used the item order entity for our skip navigations. First we fetch all skip navigations from the order entity. This is only here to prove to ourselves that we indeed no longer have any skip navigations on that entity. The same would have been the case if we had looked at the item entity. And next we fetch all item orders related to the order with ID 1 from the database. Notice here that to do so we need to include the item order entity on the order entity. The next bit of code here fetches all items contained within the order with ID 1. It does so by fetching the order with ID 1 from the orders collection, making sure to include the item order entity. Since it is not the relation entity that we're interested in, but rather the actual items within the order, we also need to include these, which we do by calling the thenInclude method and specifying the item instance on the item order. We then call the select method on the item orders collection of the order with ID 1. Instead of simply fetching the item contained within each of the item order entities, we take advantage of the fact that our item order entity contains additional information about the item in relation to the order, and instead returns an anonymous type composed of relevant information about the item itself, as well as information related to the specific order, by also returning the quantity and order date. This might seem like a somewhat roundabout way of fetching information about the items contained in an order compared to using the skip navigations. But extracting the information stored in the item order entity together with its corresponding item like we do here would have been much more cumbersome without the indirect relationship. Even though we added the payload data to our skip navigation, we would still have had to use the code that we saw in the last demo to fetch the skip navigations and make sure that we matched the right item order entity with the right item, so what the indirect relationship provides us with is far more elegant. Of course, whether to use one or the other implementation depends on what you need. If you only interact rarely with the additional information on the item order entity, a skip navigation with a payload might very well be the way to go. But in the case that we see here where we are extracting valuable information regarding our order, which will probably be needed in a lot of cases, an indirect relationship makes more sense. The last bit of code that we see here directly fetches all item order relations found in the database using the database set that was added to the database context. And now let's try to run the code. If we start by taking a step with the debugger and move past the first bit of code here, we can take a look here in the watch view where we can see that as expected, no skip navigations were found on the order entity. And now let's take one more step with the debugger, past this bit of code here. If we take a look in the watch view, we can see that we get back two item order entities, which relate to the two items that are contained within the order with ID 1. If we expand the first item order instance, we can see that it relates the order with ID 1 to the item with ID 1. And if we expand the second one, we can see that it relates the order with ID 1 with the item with ID 2. This is exactly what we would expect to see, and is also what we saw when we tested the skip navigation with payload. One thing to note here is that the order instance on the item order is populated, but the item entity is not. This is because we fetched the item orders through the order instance, so it automatically populated the order. If we had wanted to also fetch the item, we would have had to use the include method. The reverse would of course have been true if we had fetched an item order through an item. If we take another step with the debugger, past this bit of code here where we fetch information about the items, we can see here in the watch view that we get back two instances, just like we would expect. Here we see information related to these items, and we can see that 10 instances of item 1 were ordered on the 1st of January 2020, and that 0 instances of item 2 were ordered on the 12th of November 2022. The reason why there is a 0 quantity on item 2 is of course that we've only changed the quantity for item 1, which we did during the previous demo. If we now take one more step with the debugger, past the last bit of code here, we can see that we have fetched all the item orders in the database. And as we can see, we get back 5 instances, which is what we would expect. And if we expand the first one, we can see that it corresponds to the first item order of the order with ID 1, which we just looked at, which related the order with ID 1 with the item with ID 1. And it has the quantity 10 and an order date, which is the 1st of January 2020. In the demo that we just saw, we finalized transforming our direct many-to-many mapping that used skip navigations and property back entities into an indirect many-to-many mapping that used the item order entity, which we originally created to serve as a join entity between the items and orders tables for the skip navigation with a payload. We saw that while this provided us with a much easier way of accessing payload data, it required us to change all the code that interacted with the join between items and orders. Now that we've created an indirect mapping between items and orders, let's see how we can use this mapping to create, update and delete relationships between the items and orders in our database. We're now back inside Visual Studio and we're looking at the program class of the console application. The first part of the code repeats what we previously did when we were working with skip navigations with payload, except that this time we are updating the order with ID 2 instead of the order with ID 1. So the first bit of code that we see here fetches that order from the database, whilst including the item orders that are related to it. And then the next bit of code that we see here fetches the first item order from that order's item orders collection. If we quickly head over to the Server Explorer, we can see here in the items orders table that there is currently only one item order that relates to the order with ID 2, which is this one, which relates that order to the item with ID 1. And as we can see, both the quantity and the order date still have their default values assigned, so they haven't been changed yet. So if we head back to the program class, we can see that the next thing that we do here is to change those two properties, setting the order date to the 1st of January 2010 and the quantity to 20. And the next bit of code here creates a new item order instance, which we'll use to simulate adding an extra item to the order that we're working with. We do so by setting its order's ID to 2 and the item's ID also to 2, which translates to adding the item with ID 2 to the order with ID 2. We then set the order date to be the 1st of January 2010 and the quantity to 5. And then in the next bit of code here, we add our new item order to the item orders collection on the order instance. And following this, we call the save changes method on the database context. In the next bit of code that we see here, we remove the item order that we just added and once again call save changes. Now let's run the code and see this in action. If we start by moving the debugger past this first bit of code here, we can see the order that we just retrieved here in the watch view. And as we can see, if we expand its item orders collection, it just contains the one item order that we just saw in the database. If we then move the debugger past the next few lines of code here, we first fetch and update the item order already in the item orders collection, and then we create a new one which we add to the item orders collection on the order. And finally we call the save changes method to persist the changes to the database. If we now head over to the Server Explorer and once again have a look at the item orders table, we can see that the existing item order has had its date and quantity updated and that a new item order has been added relating the item with ID 2 to the order with ID 2, just like we specified in the code. And as we can also see, it has set the order date to be the 1st of January 2010 and the quantity to be 5. If we now head back to the program class and move the debugger past these two lines of code here where we remove the item order we just added, we can head back to the Server Explorer and see that it has indeed disappeared. In the demo that we just saw, we learned how we could use our new indirect mapping to create, update, and delete the relationships that exist between the items and the orders in our database. This module has been a deep dive into mapping many-to-many relationships. We saw how AF-Core implements a direct many-to-many relationship with skip navigations for us by using property-backed entities, and we looked at how we can interact with these entities by looking at the relationship between items and orders in our CarveDrug data model. We then introduced a join entity to use with our skip navigation, and we saw how we could augment that entity with payload data. We then saw how we could use that join entity more explicitly to create an indirect many-to-many relationship between items and orders. As we saw, we have several approaches that we can take when we want to map a many-to-many relationship using AF-Core. Each of them has advantages and downsides, and choosing the right one is all about finding out how you need to use the relationship. Skip navigations are ideal for simple cases where we are just interested in the join between the two entities and no extra data is needed. In case we later on find out that we do in fact need additional data, we basically have two ways to choose between. One thing that we can do is to add a payload to the skip navigation, but it may not always be the easiest thing to work with in our code. Another approach we can take is to create an indirect many-to-many mapping, which has the advantage of being more explicit and allows us direct access to the join entities without having to fetch skip navigations from our entities. And of course, we can also make a stepwise transition from skip navigations to skip navigations with payload to finally an indirect many-to-many relationship, just like we saw in the demos. Whether we should choose to implement an indirect mapping or skip navigations with payload depends a lot on our use case. As mentioned during the demo, one thing that factors in is how often we want to interact with the payload data. If we only want to do so rarely, the convenience of the skip navigations might outweigh the extra work that we need to do when working directly with the join entity. Whereas a case such as the relationship between items and orders that CarveDrug want to model probably calls for an indirect mapping. This is because we'll be using the payload data in many scenarios, And of course, as we've just mentioned, we can change the mapping at a later point as our needs evolve.